All right, here's our free response question from the second practice test. A recent study was interested in determining the optimal location for fire stations in a suburban city. Ideally, fire stations should be placed so the distance between the station and residences is minimized. One component of the study examined the relationship between the amount of fire damage, Y, okay, so that's our response variable, amount of fire damage, and measured in thousands of dollars, and the distance between the fire station and the residence in miles. So distance is the explanatory, amount of fire damage is the response. Okay, the results of the regression analysis are below. Okay. So part A, write the equation of the least squares regression line. Define any variables used. Interpret the slope of the equation in context. Okay, so y hat equals a plus bx. Let's always start with that. Okay, now the y variable, we already know that's fire damage. The explanatory variable, we already know that's distance. The coefficients a and b you'll find in the column called coefficients. Okay. The constant is the intercept, and the other value below it is the slope. Okay. All right, so we will write predicted fire damage is equal to 10.28 plus 4.92 times the distance. All right, so that's the equation. We define the variables because we used context in our equation. Okay, the second part, interpret the slope of the equation in context. Okay, so slope, let's change colors here. Slope is the change in y versus the change in x, and the slope value is 4.92. Okay, now as a ratio, it'd be 4.92 over 1. Okay, so whenever the x variable changes by 1 unit, so that is whenever the distance increases by 1 mile, the y variable is predicted to increase by 4.92, or the amount of fire damage is predicted to increase by $4.92 thousand. Okay, let's just write that as a sentence. When the distance increases by 1 mile, the predicted amount of fire damage increases by 4.92 thousand dollars. All right, or $4,920. Okay. All right. One of the key words that needs to be in this interpretation is predicted, right? So the slope tells us the predicted amount of change in the response variable. Okay. Part B. A home located 3 miles from the fire station received $22,300 in damage. Okay, so that would be equivalent to 22.3, right? Because that's how we're measuring in thousands. Okay, use your equation in part A to calculate and interpret the residual for this observation. Okay, so let's get the predicted amount for a 3-mile distance. So we'll copy our equation here and just replace the variable distance and input a 3-mile distance. Okay, I'm going to do the calculation off screen here. So 10.28 plus 4.92 times 3 gives 25.04. So the predicted amount of fire damage is 25.04. Okay, this is the actual amount, and this is the predicted amount. Okay, and so the residual is actual minus predicted. So that's going to be 22.3 minus 25.04, which is negative 2.74. All right, so we calculated it. Now we need to interpret it. So we need to write a sentence explaining what that number means. Okay, so we could say the actual amount of fire damage was $2.74 thousand less than what the model predicted for 3 miles. Okay. The actual amount of fire damage was $2.74 thousand less than the model's prediction for 3 miles. Or in other words, the model is over-predicting how much fire damage there will be. All right, part C, identify and interpret the correlation coefficient. Okay, so the correlation coefficient is represented as R, and the computer output gives us R squared. Yeah. So we just need to unsquare that number to get R. Also check whether it should be positive or negative by, you can look at the slope. The slope will tell you the direction of the relationship. All right, so look, the slope is positive, right? So that means that we have a positive direction. R will be positive. Okay. So R will be the square root. All right, let's just start with this. So R squared is equal to 0.9235. Okay, and then now we can unsquare both sides. So R is approximately 0.9235, and we get 0.96. All right, so that's the value, and now we will interpret it. Well, did it ever say, it never gave us a scatter plot. Did it ever say that the form was linear? It does not. Okay, so I don't know whether the form is linear or not, because we don't have a scatter plot, we don't have a residual plot, and the question stem does not mention that it's linear. Okay, so I will just simply say this. The relationship between distance and fire damage is positive and strong. Okay, positive because we know the correlation is positive. We know that because the slope was positive. And then strong because this value is pretty close to 1. Now, if I had a scatter plot which confirmed that the form was linear, then I would have said the linear relationship between distance and fire damage. But since I don't know that it's linear for sure, I won't include that in the sentence.